In this video, we'll talk about confusion matrix. Confusion matrix is a powerful tool in machine learning that provides a visual representation of the performance of a classification model. It is a matrix that summarizes the prediction of a model and compare them to the actual values of the target variables. Confusion matrix is widely used in evaluating the performance of machine learning models, especially in binary classification problems. So these matrices are represented in a matrix format with the actual value or true value on one axis and predicted values on the other axis. Confusion matrix consists of four important metrics, that is true positive, false positive, true negative, and false negative. So let us take an example to better understand the concept of confusion matrix. So suppose we have a data set of 100 patients, out of which 80 patients are healthy and 20 patients have disease. So positive if they have disease and negative if they are healthy. Now we train the binary classification model to predict whether a patient is healthy or has a disease. So after applying the model on the data set, we get the following results. So 15 patients are correctly predicted to have disease. So the prediction is correct with the true class or the real outcome. So it will come under true positive. 5 patients are wrongly predicted to have disease. So that 5 patients are actually not having disease, but the model predicted that they have disease. So false positive, so false are wrong predictions, and positive for the actual values, that is they have disease. 75 patients are correctly predicted to be healthy, so they will come under true negative, so true for correct prediction and negative for patient is healthy. And finally, 5 patients are wrongly predicted to be healthy, so they will come under false negative, so false for wrong prediction and negative for patient is healthy. So this is represented on confusion matrix like this. So let us recap. In the confusion matrix, the row represents the actual value while the column represents the predicted value. So the top left square denotes the number of true positives, that is 15, which means the model correctly predicted that the 15 patients have disease. The top right square denotes the number of false positive, which means the model wrongly predicted that 5 healthy patients have disease. The bottom left square denotes the number of false negative, that is 5, which means the model wrongly predicted that 5 patients have no disease when in actual they have disease. And the bottom right square denotes the number of true negative, that is 75, which means the model correctly predicted that 75 patients are healthy. So as you see that the yellow and the red box have predicted incorrectly, so there is an error in prediction. So let us name this box as type 1 and type 2 errors. So first let us talk about type 1 error. So in the context of a confusion matrix, type 1 error refers to the situation when the model predicts a positive outcome, but the actual outcome is negative. So this is also called false negative. For example, if the model predicts that a patient has disease, but in reality the patient does not have disease, so this is type 1 error. The consequence of type 1 error is that it may lead to unnecessary medical treatments or a wrong diagnosis, and in the case of a medical diagnosis, it can also lead to loss of time and resources due to further tests and treatments that may not be needed. The consequence of type 2 errors is that it may lead to missed medical treatment or a misdiagnosis, which can be dangerous and even life-threatening. So type 2 error is more consequential in comparison to both the errors. Also in other fields, it can lead to loss of opportunities or miss opportunities like marketing and finance. Therefore, it is important to minimize both type 1 and type 2 errors in any machine learning model and ensure that the model is accurate and reliable. So this is what we have got. So true positive was 15, true negative 75, false positive was 5 and false negative was 5. From this confusion matrix, we can calculate various performance matrices on the model such as accuracy, precision, recall and F1 score. So let us take one by one. So the first one is accuracy in this slide. So accuracy is the default matrix for classification problem. Accuracy is the ratio of correctly classified samples, that is true positive and true negative, to the total number of samples. So we added all the 4 over here. The accuracy score indicates how well the model performs overall in terms of correctly classifying the samples. However, accuracy alone may not provide a complete picture of the model's performance, especially when dealing with imbalanced data. Similarly, precision is the ratio of correctly predicted positive instances to the total predicted positive instances. Precision measures the portion of true positive predictions among all positive predictions. So in other words, precision tells us how many of the positive predictions made by the model were actually correct. It is useful metrics to evaluate the accuracy of a model in scenario where false positive carry a high cost such as medical diagnosis or fraud detection. Recall is the ratio of correctly predicted positive instances to the total positive instances, and it is given by this formula. So true positive divided by true positive plus false negative. Specifically, recalls measures the proportion of true positive, that is the number of correctly classified positive instances, out of all actual positive instances in the dataset. So in other words, recall will tell you how well the model is able to correctly identify positive instances overall. It is useful metrics to assess the effectiveness of model in identifying all relevant cases, and it is particularly important in scenarios where false negative, that is instance that were positive but were classified as negative, can have a serious consequences. So this one will just incur you high cost, while this one can be life-threatening in our example. F1 score is a harmonic mean of precision and recall, and it is given by this formula. So F1 takes care into account both precision and recall, which are two important metrics in the evaluation of model performance. The F1 score is particularly useful in situations where the classes are imbalanced, as it provides a more balanced evaluation of the model's performance. It can be calculated using the values in the confusion matrix and can be used to compare performance of different models. So in conclusion, confusion matrix is a useful tool for evaluating the performance of a binary classification model. It provides a clear picture of the model's accuracy, precision, recall, and F1 score, which are the essential metrics for measuring the effectiveness of a machine learning algorithm. So I hope you have liked this confusion matrix intuition video. Please subscribe to my channel. Until then, keep thinking data science.